Welcome, everyone, and thank you very, very much for carefully entering the space and muting, and also for joining us. We're really delighted. I'm Marcia Meskimen. I'm the director of the Institute of Advanced Studies, and this is the second event of a four-part series in our annual theme this year, which is time. And we are really excited about today's event. We have three fabulous speakers, plus also an interlocutor. We will be chaired by Peter Kavalek, who is one of the members of the time team, who are Torolf Klein, Ariana Mairani, and also Alex Zagoskin. And they will also be monitoring the chat for questions, as well as inviting questions after the event. But Peter will explain all of that in advance. I'm really here simply to say welcome to the IAS in virtual form. We are really thrilled that people would come both from outside the institution and colleagues from within to hear this really exciting trialogue today. I'm also delighted to say that we are joined today both by Professor Robert Allison, our Vice Chancellor, and also Professor Steve Rothberg, our Pro-Vice Chancellor for Research. And I'm going to turn over to Bob to say a few words and welcome on behalf of the university. And between the two of them, I think there's a bit of a double act about saying welcome before the event of time takes place today. So Bob, if I can turn over to you.
Marcia, that's very kind. Thank you very much. And can I add my words of welcome and thanks to everybody who's joined us today. I see many faces online of colleagues I know well. To those of you who are here at Loughborough, good afternoon. If you're west of us, good morning, and if you're east of us, good evening. Whichever part of the world you're in, I'm delighted, as I know Marcia is, that she's come to join us. The Institute for Advanced Studies, for me, is a really important part of our research endeavour at Loughborough. And I must I must confess, as Marcia and Steve Rothberg know, I have a personal interest in it. And the reason for that is, of course, as I know you'll all recognise, as the Vice-Chancellor at Loughborough, I'm now a decaying academic. But at that point in my career, when I was deeply embedded in my research, some of the most interesting discussions that I had and some of the most stimulating ideas came from talking in an interdisciplinary, or dare I say, a post-disciplinary way, around themes which weren't about my research per se, but impinged on them. And I think the reason for that is, number one, is it made me think differently. And number two, it opened my ideas to think about my own research in ways that I wouldn't have done if I was only talking to people in my part of the academy. Marcia has, as the director, I think, done extraordinary stuff. She's done extraordinary stuff with the IAS full stop. But I think the way in which we're all meeting today is testament to that. If I'm being honest with you all, this time last year, I was hoping that I wouldn't have to learn how to use things like Teams and Zoom. And words like "you're on mute" weren't in my vocabulary. But I realised that even at 59, I was at a point where I wasn't going to be able to escape this. But I think what I've learned over the last period of time is you can still have discussion, debate, get groups of colleagues together like this from many different parts of the world. And in fact, you can perhaps do it in a way that it would have been much more difficult to do if we'd not realised the power of this sort of opportunity. So while I suspect we all crave getting back to something that's a little bit more like normal, I think that what Marcia and the rest of the IAS team have done in running debates and discussions like this has really been excellent. Marcia, thank you and the team very much indeed. And thanks particularly to those who are going to be leading the discussion today. I do rather like the idea about time, disaster and decision making for two reasons. As Marcia knows, I do like IAS themes that can be interpreted in very different ways by many different people. And I'm sure we're going to hear something about that this afternoon. But I do think there's something where those words are of the moment in terms of some of the challenges that we've had to deal with personally in our private and our professional lives, and how different governments around the world have responded to some of the most immediate concerns that we're all having to deal with. So thank you very much for joining us, particularly to those who will be leading us. And I'm looking forward, I will stay with you, as you know, for some time, Marsha, because I'm very interested to hear some of the discussion and debate. And Marsha, thank you to you and the team for the organisation. And I'm assuming, Marsha, that you would like me to hand on to Steve Rothberg, but I see you've unmuted, so I'll go back to you to tell me whether I've been right or wrong in that assumption.
No, that's absolutely right. I was just going to make sure that you felt comfortable about what was happening next. So if I could ask you, Steve, to say a few words and then hand over to Peter to chair the session. Thanks, guys.
Thank you, Marsha. Let me just check, Marsha, because I can't see myself on the screen, but you can see me, I think. Can you? Is that right? Yeah, okay, great. And you can hear me okay. So thank you, Bob, and Marsha, thank you for giving me a chance to say a few words. I'm Steve Rothberg. I'm the Pro Vice Chancellor for Research. And I think if the picture is right, I'm speaking to you live from the bus stop just outside the Hazelrig building, where the Vice Chancellor was speaking to you from a moment ago. I'll be brief, but it is a great pleasure to have the chance to say a few words. A couple of sentences of history about the Institute of Advanced Studies. So we launched our Institute of Advanced Studies only in May 2017. I agree entirely with Bob's assessment of the important contribution that Marsha and indeed her predecessor have made to the progress that we have made in such a short amount of time. We've welcomed 214 visiting fellows from 35 countries at the last count to our Institute of Advanced Studies programs since May 2017, and it's absolutely the case that IAS, as we know it, has won a place in the intellectual hearts of colleagues across both of our campuses in such a short space of time. A couple of years ago, IAS became a homeowner. So those of you who are with us today, but who are not Loughborough colleagues, I do hope that at some point in the not too distant future, we'll be able to spend time together and we'll be able to host you at our IAS home, which is International House, quite literally at the heart of our Midlands campus. And then just last year, or for this academic year, we've added the residential fellowship scheme to IAS, which has been a very significant next step for us. And I think do we have our third residential fellow about to arrive, or already arrived, or not quite yet? Not quite yet. Not quite yet. So we've had two, and we're looking forward to our next one. And we have a programme for this year. As Bob said, one of the really enjoyable things about the roles that we have, and certainly the case for me as a Pro Vice Chancellor for Research, is the time that I can spend listening to colleagues describe their passion for research in a diverse range of disciplines that extend way, way beyond my own. And I feel this has really been taken to a next level through the Institute of Advanced Studies, whose events bring colleagues together, not just Loughborough colleagues, but colleagues from the worldwide academic community across disciplines, colleagues that don't routinely engage to discuss topics that are so very clearly, when we bring people together, of great mutual interest. And that really has been a privilege to have been able to play a part in and to have participated in. And today is yet another great example of bringing colleagues together from around the worldwide academic community, from different disciplines, to engage on a matter of mutual interest. So a warm welcome to everybody today, especially to guests who are speaking and other guests who are participating from outside of Loughborough. I'll leave the formal introductions to Peter, but thank you to everybody for coming to join us. I'm sure this is going to be a fabulous Wednesday afternoon, and I hand you back to Marsha.
Peter, if I can turn over to you. We are really thrilled by the particular trialogue we're about to have and the fabulous speakers and fellows today. And I'm sure Peter will explain to you the format, but we're really looking forward to this. The first time event was particularly exciting and quite vibrant in its conversation throughout and after. And I expect this one will carry on that exciting trialogue format. So Peter, please.
Yes, it will. It certainly will, Marcia. I'm sure of that. So thank you for all the introductions to Steve and to Bob. Very helpful to have you set the scene like that. And of course, a few thank yous to the IAS and Marcia, Laura, Helen, and all that's done the work to set us up here. I need to mention, of course, my colleagues in the Time team. It's a great club to belong to. Throughout for all the work, Alexander and Ariana. You'll meet them as we go through today, everyone. And then just very quickly, some housekeeping then. I mean, you're all very welcome, all very, very, very much welcome. And it will be a very nice session and I think very creative, but we need some etiquette. And the etiquette we need is that to watch those mute buttons and deploy them during the speakers. But after the presentations, then you are actually welcome to, use your voice. Welcome to unmute after the presentations, and we'll, as much as time will allow, we'll get some discussion going. Normally during the presentations, the default will be to have your cameras off also. That's the default. But again, at the end of the presentations, nice to have the cameras on, or as you choose, I would also advise that I think it's nice when you use chat throughout, use the chat discussion throughout, we can have a bit of a vibe going. Some questions you might want to raise there early, and there might be some comments, some questions, some clarifications. And again, myself and Ariana will work to try and pick up as many of those as we can as we go through. I suspect we might be overwhelmed by them, but then I think we'll probably leave an archive to history somewhere in the cloud. Very, very pleased that we have such great speakers for you. I won't say much more at the moment, but I will introduce David later. I will introduce Jason later, and very privileged to have them. Please note that we're recording the session also. And now I'll just ask my colleague Alexander just to introduce Natalia to you, and then we're truly underway.
Well, this is my great pleasure to participate in this, and especially to introduce Dr. Natalia Janson. She got her PhD in physics from Saratov State University in Russia in 1997 for the work devoted to building mathematical models of living systems based on the experimental data. And she has this years of experience working on theory of nonlinear dynamical systems, chaos theory, nonlinear data analysis, all this very important thing with applications in areas like biology, medicine, engineering. And she's really good at interdisciplinary research and collaborations. Has over 60 research papers and co-authored a book on synchronization. This is very fascinating phenomenon. And since recently, she focuses on understanding how the brain works, how the mind works. Now, to say that a few years ago, she gave a TEDx talk about mathematical approach to resolving the mind-body problem, something which was puzzling philosophers for, well, millennia, I would say. And today she will discuss mathematical perspective on how brain and mind can be discussed in the context of time. So please, I'm going to enjoy this, really.
Thank you very much indeed, Alex, for introducing me. It is my pleasure to be here. And I'm going to start by sharing my screen. Could you please kindly confirm if you can hear me? You can. Okay.
Yes.
Yes.
Okay, thank you very much. In the introduction by Alex, Alex already mentioned that I'm interested in a mathematical understanding of such an important philosophical problem as the mind. And indeed, I gave a TEDx talk in 2016 devoted to a possible mathematical solution. But today, I have maybe about 30 to 40 minutes to discuss what is believed to be the most challenging, or one of the most challenging problems ever encountered by people. And I'm sorry, I forgot to switch on my camera. Yes. Let me first of all start from explaining how my research discipline is even related to the theme topic of this workshop. Well, I have to say that it is related directly because I'm working in the theory of dynamical systems, and this theory is especially devoted to constructing mathematical models of real-life objects, such objects which spontaneously evolve with time. So if the state of an object, such as a grandfather clock or a human heart, changes with time, if they oscillate, for example, that's exactly assumes the model in the form of a dynamical system. Dynamical systems are widely used, have been widely used to model all sorts of phenomena, such as the planet motion already in the 19th century, populations of animals starting from the beginning of the 20th century. Nowadays, they model financial processes in economics. Weather models are very popular. They model elections. They can even predict election results, sometimes if we're lucky. Among the physical science-related phenomena, we can speak about chemical reactions such as Belousov-Zhabotinsky reaction, which spontaneously switches color from blue to red and back in time. Then we're talking about models to mechanical systems such as grandfather clocks or metronomes, for example, numerous electronic circuits, and living systems. Now, the theory of dynamical systems provides a box of tools for several related disciplines. One famous discipline which gained its popularity starting from 1960s is called synergetics. It is a hugely interdisciplinary science which explains how systems self-organize and form patterns and structures spontaneously. And of course, even the term synergetics assumes that we are talking about understanding how a myriad of different factors and mechanisms work together jointly and construct something which is not explainable from simply adding these factors together. So interactions working together are hugely important here. Now, theory of self-organization is very well known. It also describes how physical, chemical, biological, and even financial systems self-organize. I would like to specifically mention catastrophe theory, which uses the mathematical apparatus of bifurcations theory, which is a section of dynamical systems theory. And of course, catastrophes are related to disasters. And one of the themes of this workshop is disaster. And also, I would like to mention chaos theory. An example of a chaotic attractor is shown at the bottom of my page. As I already mentioned, we only have about half an hour to discuss the most difficult object in the universe, the mind, which is produced by the human brain, or at least modern neuroscience firmly believes so. Just to justify my claim that it is the most challenging topic to discuss, some brain facts are listed here. 86 billion neuron cells approximately in the human brain. one neuron cell typically has a few thousand connections to other neuron cells, and in fact, brain cells are not everything, are not only neurons, sorry. Brain cells also include non-neuron cells, which adds the complexity to the problem. And at each individual level, at the level of a single cell, at the level of connections between cells, at the level of cell clusters, there are intricate mechanisms operating. And of course, it is impossible to speak about all such things in detail, so I will have to make shortcuts. And there are references to support each of my statements, but I will not be including them. However, if you're interested, I can provide these references on request after my talk. I would also like to state this disclaimer. I'm not going to discuss consciousness. When I'm talking about the mind is more general than the consciousness. And in the top of this slide, there is a quotation from the Unsolved Problems in Neuroscience, published in Trends in Cognitive Sciences, which is a very prestigious journal. And this quotation says that we need to understand essentially is how the brain generates the mind, but this problem should be conceived in such a way that it does not require answering the problem of consciousness. So consciousness will be outside this discussion. So hopefully my job will be slightly easier without consciousness. Now, what about the mind? We, of course, wish to study the mind scientifically, and people have been keen to study the mind with methods of natural sciences, physics, chemistry, for a long time. However, the problem is that for any scientific studies of anything, we need a proper definition of the object of our study. Unfortunately, for the mind, we do not have such an explicit definition. And the term mind is used very broadly as essentially a proxy for intelligence, or we normally mean an entity which is behind our intelligence and our cognitive functions. And typically the mind is closely related to intelligence. And what can we say about intelligence? Is it properly defined? In fact, not quite, because numerous definitions of intelligence specify what intelligence does, which means that an intelligence system typically memorizes new things, recognizes familiar patterns, it can generalize from data, it can optimize a problem, it can find a solution to a problem, make a decision, and etc. However, there is no specific definition of what is intelligence. So we know what intelligence does or should do, but we don't know what it is. So, for example, even IQ tests, any means to assess intelligence, is via observing what the system does, what we do. And in order to switch to a mathematical study of intelligence, we need a technically specific definition. We need to understand what to look for, and we need to understand it in such a way that we could actually measure the mind, because any scientific research means that we pose a hypothesis and then we verify our hypothesis in an experiment. And for that, we need to make measurements. And just to explain what I mean, I would like to give a brief analogy with electricity. Obviously, electricity is nowadays with us. It has been known for a few thousand years, but remained as a very vague concept. Only in 1600, it was defined formally. How? As the property of attracting small objects after being rubbed. And again, it was defined as what it does. And only around 1800, the concept of electricity was specified more precisely as an electrical current. So people singled out one aspect of electricity, and they said that, okay, first of all, we have charged particles, and then they move in a certain direction, and that motion creates electrical current. So this was only one technical aspect of electricity, only a starting point, and definitely not all electricity. But this starting point, first of all, enabled applications. For example, electrical motor and electrical circuits were created and even analyzed mathematically already in the early 19th century. And also, quite quickly after the first definition was provided, already a theory of electricity was done by Maxwell. Maxwell equations were provided in 1862. And of course, now our world is shaped by electricity, and we still try to understand electricity, for example, with quantum theory. Come back to the mind, we want something like that. We want a starting point, a technical definition, which would help us to develop the theory, from which the whole theory of the mind could unfold. In fact, mathematics does have experience of helping understand the mind, and we can recall Turing machine, a very famous concept, because in fact, Turing hypothesized that thinking could amount to just going from one statement to another according to some set of rules. And this set of rules is actually known as a computer code or an algorithm. And by the way, this would be a process in time, which shows the relevance to our today's topic. And the first idea of a computer was implemented based on a mathematical idea of a computable number. And now, after that happened, our whole world is computerized. Now, because computers have been so popular, people have been trying to understand the brain in computer terms for quite a long time. It would be probably quite safe to say that the brain-computer analogy is the most popular concept of the brain. People usually speak of the brain as a biological computer and the mind as the brain software or the brain code. However, let me list three main brain-mind paradigms which are based on mathematics. And I would like to emphasize that these paradigms are really only three. I'm going to mention three paradigms, but there are plenty of other theories also based on mathematics. They are much less popular, so I will not mention these other theories. So if you have heard of anything which I will not mention today, that's just because I don't have too much time. But anyway, I will start from brain as a computer paradigm and mind as a software. Well, it has been long believed for over 70 years now that if our computers become more and more powerful, eventually a human-like intelligence will emerge in such computers. However, 70 years later, there is no human-level intelligence inside in computers. So something might have been not quite correct with this assumption. However, there is a second problem, which I think is more obvious here. We know, at least that's the current basic assumption in neuroscience, we know that the mind is produced by the brain. The mind is the consequence of the brain existence. However, in a computer, software and hardware are quite independent of each other because software is produced by a human coder who is a super intelligent creature as compared to the computer, and it is imposed on the computer hardware. So hardware does not give rise to software, which is not so in the brain. Then the second brain paradigm is that the brain is a neural network. Well, this follows from what we know from biology. This we know for about 150 years or even longer, that essentially the working horses of brain computation, as they call them, are neurons, individual neuron cells, and they're all connected to each other in a certain manner. And one mathematical apparatus which is very suitable to describe connections between anything is graph theory. However, graph theory, it might be good, it might be helpful. Graph theory is not based on biology because it really ignores an essential part of brain operation, which means that neurons are firing spontaneously. Graphs do not take this into account. They do not take into account evolution of neurons and of the brain in time. Now, the third maths-based brain-mind paradigm is also of a neural network, but with a focus on dynamics. And now the dynamical systems theory is very relevant here. Why? Because for a single neuron, which is shown at the top right corner in my slide, here is, of course, a single neuron is a hugely complicated device, even just taken individually, regardless of the brain. However, what is possible to do? It is possible to apply the laws of physics and chemistry and to write down, to produce an equivalent electronic circuit for the single neuron, and then electronic circuits can be handled mathematically, and we can apply the laws of physics, very famous laws of physics, and construct ordinary differential equations. And I show these differential equations for the neuron. I don't want you to think too much about them, because that gives you just an idea of how they look like. But anyway, when do we say that a mathematical model of something is good? It's when this mathematical model reproduces the observed behavior and also allows us to predict the behavior which was not yet observed. And in this sense, we can say that a given mathematical model is a mathematical representation of the actual physical material device. And for this Hodgkin-Huxley neuron model, you can see this graph shows the actual measurement from a neuron, and the graph at the bottom shows the solution of the model equations. So it has some good evidence of validity. Now, what we're trying to solve, what kind of thing we're trying to find, because we want to find some candidate, some technical definition for what the mind could be. And of course, we're not looking for a comprehensive definition, we just need a starting point. Despite the deficiencies of the brain-computer analogy, let us use this analogy just for the beginning. Essentially, we're trying to find the rules or code which controls the firings of individual neurons in the brain. And if we know how neural firings are produced, we will know why the whole body behaves in this manner. Why is that so? It's because it is very well known, very well established fact that the brain sends signals to our muscles, and these muscles control what we do, how we walk, how we stand, how we speak, and etc. And once we know why neurons in the brain fire in a certain manner, we will know why the whole body behaves in this manner. So we need to focus on what makes neurons in the brain fire in a certain way. However, while looking for the rules which are not like computer software, we want these rules to emerge from the brain architecture, from the structure of the brain. And of course, we would like to know how these rules could be read off the brain, or at least in principle, maybe not immediately, because the science might not be so well developed at the moment. The method we are going to apply will be probably relevant to how police detectives work, or maybe intelligence officers work. And this is also within the topic of today's workshop, because it is about intelligence. So essentially, we're going to specify the attributes of the culprit, or the suspect. In our case, it will be the mind. We're going to find some object in mathematics which will match these attributes. And then there will be usually some indirect evidence, and we will check our suspect against this indirect evidence. So let's start. Why dynamical systems are even relevant to the brain? That's because they describe systems, not just any systems, but systems which evolve with time And the key word here is spontaneously. Spontaneously means that they evolve, they change their state with time, such as a grandfather clock or a heart cell, because they are made this way. So it's their internal structure which causes them to evolve with time. And just a few examples of such systems are shown here. On the left, I have a movie showing a grandfather clock. Its pendulum oscillates because the clock has a certain structure. It's not because anybody is kicking the pendulum and makes it oscillate with a given period, amplitude, or shape. Another example is a recording of some chemical concentration of a certain substance from a single heart cell, and you see a single heart cell oscillates on its own. And then the whole heart as an organ, in this example, it is the heart of a frog, which is as isolated, which is taken away from the frog. The whole heart is contracting spontaneously on its own. And of course, we know that neurons in the brain also fire spontaneously. In what sense? In the sense that nobody from outside, there is no God or external engineer which tells each neuron cell to fire right now and not later, not earlier. So in this sense, the whole brain is operating spontaneously. Although, of course, we know it is affected by sensory stimulus, by what we hear, see, sense, or smell. Now, a little bit of background information. Why dynamical systems could be good? It's because the key component of a dynamical system by construction is a set of rules governing this evolution. So we are defining a dynamical system by specifying the set of rules. And you see we are looking for the set of rules for the brain. Now, how do we obtain a mathematical model in the form of a dynamical system? Essentially, when we model from the first principles, we take into account all components of the system and all laws of physics or, say, chemistry, which govern interaction between the components and govern the individual behavior of the components. So essentially, we collect information from every single component or law related to the system and convert this information directly into the rules of behavior. That's the modeling process. And in the theory of dynamical systems, these rules, plural, are in fact expressed very conveniently as a single object, just a single mathematical object, which has a very, well, maybe slightly difficult name, phase velocity vector field. I will refer to it as vector field for brevity, but it is essentially just a single object, and I will explain what this object is like a little bit later. And this is expressed via mathematical functions. And if the brain consists of many small dynamical systems describing neurons, then the whole brain is a large dynamical system. So we might actually be quite close to the answer. And I feel that although mathematics is probably not the easiest topic to consider at such a general conference, but I feel that it is really necessary to convey at least the basic idea of a dynamical system. So I'll try to do my best to be as simple as possible in my explanations. So just to illustrate the simplest possible example, a pendulum. A pendulum is an example of a system which oscillates by itself. It consists of a bob, a rod, and this thing is attached to some pivot. And usually if we kick this bob, the pendulum starts oscillating spontaneously. And the first step in any modeling is to identify what is constant in the system, what does not change with time. We call such things parameters. Here, bob mass is constant, the length of the rod is constant, and also acceleration due to gravity is constant. And of course, while identifying parameters, we ignore a million of very, very small factors because we believe that they do not play such an important role. Then the second thing to do is to identify what changes. And here we know that an angle here changes, and also, just to cut a long story short, trust me, we take into account that the angular velocity theta is also changing, and it does. And then we formulate the model. How? In our particular example, we collect all laws of physics which are relevant. They are formulated as these three equations. Some of them are differential. This one is differential, two are algebraic. Anyway, we combine them. I will not comment on how we do this. And essentially, we arrive at a single equation which describes how the phase angle evolves with time. The trouble with this equation, although it looks quite simple, is that it is not solvable analytically, which means that we have a model, but we can't solve it. We can't use it for any prediction. What's the use of such a model? Well, the solution came in the form of the so-called geometrical approach to dynamical systems, introduced by a French mathematician, Henri Poincaré, in the 19th century. And he suggested to just do a simple, well, not as simple, it looks simple, but it is actually a breakthrough trick. We take the previous model and essentially change variables. You can regard this as just basically changing notation. And we arrive at a system of two equations. But again, this might not say too much to you, so don't pay attention. It is not really important. What is important here is that geometrically, we can represent our equations with such a geometrical object called phase velocity vector field, or just vector field. What is that? So you know a pendulum here oscillates in a three-dimensional space around us. And you might think that it would be very natural to follow how the bob changes its position in this three-dimensional space. But that's not what the theory of dynamical system does. It does something much more elegant. We kind of forget about three-dimensional space, and we introduce a new space. And instead of x, y, z coordinates, we introduce the following coordinates. We introduce coordinate x1, which is the current angle of the pendulum, and coordinate x2, which is the current angular velocity. Current means now, at this particular time. And essentially, all we know about the architecture of the pendulum, about the physical composition of the pendulum, and about the laws of physics is all translated into the shape of this field. Field means that at each point in this artificial abstract plane, phase space, we have an arrow which tells us exactly, directly, what our pendulum will do next. So for example, if we start from that angle and phase velocity, that's angle, that's phase velocity, we start from here, we will know what our pendulum will do next. I'm very sorry. It will just basically follow the arrows, and it will oscillate, generally it will oscillate. So that's the idea of a vector field. If we know this geometrical structure, we will be able to predict what the system is doing, even if we do so numerically. And by the way, all computer methods which are currently used to solve differential equations, they are all based on this velocity vector field, although maybe it is not explicitly specified in the description. But this is just the basis for that. And just a very simple interpretation of a vector field, what it does. Imagine that we're working in some abstract space where x1, x2, x3 are not x, y, z coordinates of 3D space, but say a phase angle of an angular velocity and something else that would be for the pendulum. Also for the neuron, x1 could be, say, current, electrical current through the membrane. X2 could be, say, electrical voltage through the cell membrane, and X3 could be, say, chemical concentration of potassium inside the cell. And all these things change with time spontaneously. And in this space, at each point, we place a vector, an arrow of a certain length and direction. And then essentially imagine that at each point, we have a footballer who does just one thing. It catches the football from where it arrives and kicks it in an appropriate direction with an appropriate speed. That's it. And we have a footballer at each place in this space. And essentially, these footballers kick the football and they create the observable behavior, the trajectory. Now, what is important in this velocity field? It is essentially two things in one. First of all, it is a mathematical representation of the physical structure of the device which we model. On the other hand, it is an explication, it is an explicit mathematical representation of the rules controlling, governing the behavior of our device. So essentially, this vector field allows us to go from the physical device to a single object describing all factors operating within a single device. So instead of having a myriad of factors here, we can consider just one object with its shape. And because vector field does specify the rules of behavior, look, it is very similar to the computer code, to the software. And if for the whole brain, we can identify, we can specify the velocity vector field, then we will essentially obtain the brain code, the brain software. And it will be not just the code created by a human like in computers, it will be the code created by the brain architecture or emergent from the brain architecture. And I would just like to check if there are any questions. I don't see any questions in the chat.
Questions, Natalia. We've got a whole discussion on the meaning of the universe going on here.
Right.
So, so well done. You started something.
Okay, yeah. Then I will probably
shall I select for
because
you?
There are no questions in the chat. So thank you. Share. Right. However, the brain has been described as a dynamical system for at least 30 years now. To this or that level of approximation, of course, there's always an approximation. The question is, why is this brain paradigm why did this brain paradigm not lead to our complete understanding of the mind? Because we know if the mind is produced by the brain and we have a valid model of the brain as a dynamical system, so why don't we understand the mind yet? The problem is that within standard mathematics, within standard theory of dynamical systems, we can only build models for systems whose architecture is fixed. However, brain is very different, very distinct from anything we know, really, anything we know of any devices, either handmade by humans or even existing in the living world, because I said that the brain is somehow similar to cancer in one of its properties, plasticity. That means that the whole brain architecture, the whole brain connectivity changes with time, continually, non-stop. And it is not a random occasional change. This change occurs all the time. Essentially, 5 minutes ago, your brain was different to what it is now. And it is the brain plasticity, it is the changing of the brain connections, and not just the brain connections, changing of the other parameters inside the brain. It is associated with learning. Learning occurs thanks to the change in the brain architecture. And this is a very well-established fact in neurobiology. Well, if a velocity vector field can capture the brain architecture at one time moment, then if this brain architecture changes with time, then the velocity vector field of the brain must change with time too. That's the logic. However, the brain plasticity is not imposed externally, because connections in the brain change not because there is some external engineer which tells the brain that your connection, this connection at this time moment must change from this value to that value. No, this is all happening spontaneously in a self-organized manner. So brain changes itself by itself. So and if this is the case, so in fact, there is no such thing, well, at least there have been no such thing as a self-organized velocity vector field in mathematics. And my argument is that it's because of that this paradigm of the dynamical system as a brain model, it's for this reason, it so far failed to provide a very good explanation of the mind. However, if we could introduce such an idea, the velocity vector field of the brain, which evolves in time spontaneously, maybe the problem could be solved. And that's exactly what I did in my recent paper together with my PhD student. And I will talk about it shortly. So basically, the mathematical hypothesis which we could formulate is as follows. Well, we know that brain learns by modifying its architecture. But in mathematical terms, it can be translated as brain learns by modifying its velocity vector field, which means by modifying its rules of behavior. And this actually makes sense, because what does it mean that we learn something? We learn and we automatically modify the rules which we follow when we respond to stimuli. For example, if somebody gives me some bad piece of food, which is maybe poisonous or just unhealthy, I have never seen it before. And what do I do when somebody offers that to me? I try to eat it. However, if I do not feel well after that, I change my rules of behavior and I will not accept the same piece of food later. So maybe I can say I modify the velocity vector field of my brain. And of course, the brain is strongly affected by all our sensory stimuli, and the velocity vector field must be affected by them. And one crucial part of this mathematical hypothesis is as follows. This is actually crucial. This is only a hypothesis, not proved, but hopefully it will be possible to verify this later. Because the brain self-organizes according to some deterministic rules, and these rules are partly revealed by neurobiologists. For example, rules of brain plasticity are formulated as, for example, Hebgen learning rules or their modifications. I'm hypothesizing that the evolution of the brain's vector field is also obeys some deterministic rules. This is a guess, but maybe quite a reasonable guess. And moreover, we know just one or maybe two objects in the universe which are plastic. And I am told that in addition to the brain, cancer cells are also plastic because they adapt their structure all the time. So maybe intelligence might be present not just in the brain. Maybe we can create an intelligent machine without having a brain structure. And anyway, we want to reveal the laws of cognition, the principles of cognition, the principles of a brain, and then we could perhaps construct a machine operating based on these principles. And the principle, you see, I'm almost finishing. I know I had about 30 minutes or 40 minutes, as I was told. I'm finishing by giving you an illustration. This is the simplest illustration of the idea which I could think of. It is a rough analogy with a memory foam mattress. If you think of the velocity vector field as basically a surface of a mattress with a memory foam, and if we can imagine that a sensory stimuli, say in the form of a musical note, is represented as a drop of quicksilver at one point on this mattress here, this quicksilver drop will create a dent at a certain location, and this dent will remain here. But if we do not receive any more stimuli, the dent will be disappearing gradually. So that would account for the memory loss, for forgetting. And suppose we are perceiving many musical notes, and there will be a sequence of quicksilver droplets on our memory foam, on our mattress, and they will essentially shape the profile of our mattress. And you see what is good in this model, in this very abstract model, very conceptual model, if I can say so. What is good here? Our model shows how memory can be created from just a single input. One input already creates the whole class, And also we know that if the second droplet representing a second musical note launches on this mattress, then what happens to this quicksilver drop? It creates a small dent in the mattress, but also it will go to the bottom of the well which was already created, and etc. But if it is quite far away from the original well, then it will create its own memory, its own well in the mattress. So that's a very rough idea of the simplest possible plastic dynamical system. And I will try to show you just to show the principle. Can we create a very abstract dynamical system, not based on a neural network, but implementing this principle? Will it perform basic cognition? Oh no, I'm very sorry, you can't hear it. Right. I don't know why, but I can't hear the sound. Could you please tell me, can you hear anything at all? Probably not.
Sadly not, Natalia. No.
Right. Very sorry about that.
Just one of those quirks.
So you can hear me, but you can't hear the sound.
Right.
Then I will promptly move on. You know, the thing is that maybe I can convince you to trust me here. This is essentially what happened here. We implemented this idea in a computer code. Then we allowed it to listen to a song, "Mary Has a Little Lamb," played by a human musician on a flute with all these imperfections, with all the noise. And the system knew nothing else. It did not have any information. And then it was able to single out individual musical notes, individual segments of this melody, and essentially it was able to single out the melody itself, and it also cleaned it from noise as well. So basically it worked. Also, we did the same analysis with visual examples, but again, I don't have time to illustrate this. Anyway, we also, so velocity vector field is a good candidate for the brain code, and if we assume that it is spontaneously evolving. So the main hypothesis here is that the principle of cognition, the principle of the brain operation, which is behind the mind, is that, yes, the brain does create a velocity vector field as a set of rules, but this set of rules is spontaneously self-organizing in response to sensory stimuli. And memories, individual memories, are imprinted where? On this velocity vector field, not on any particular physical substance or in any physical location, but these are imprints, indents on the velocity vector field, basically like splashes of these arrows. And there is plenty of indirect evidence supporting this hypothesis from several disciplines. Maybe I can actually start from philosophy, maybe, because philosophy, of course, was trying to understand the mind for millennia, for centuries at least. But in 1949, since 1949, they actually started to try to define the mind as a measurable, maybe physical object, because everybody was keen to make the mind amenable to natural scientific methods. And the recurring idea has been that the mind is some kind of a field created by the brain. And you see, there is a correlation. Velocity vector field created by the brain, mind is a field. Some people said that it was just the physical force field produced by the brain. Some people specify that it is actually the electromagnetic field produced by the brain. And other people said that actually no, it is probably some non-physical force field, some mental field produced by the brain. And the word field appears all the time and correlates with my proposal. We also maybe can make a reference to psychology, that it is known that memories, well, we know that we can remember something from the very first observation. For example, if we see the cat just for the first time, we will essentially know the concept of a cat. Modern computers, modern artificial neural networks do not do this, because they will recognize a certain object, such as a cat, but they really need a lot of training data. Also, neuroscience, biological neuroscience, gives us quite a lot of evidence. For example, the current neuroscience theories suggest that memories are kept where? In neural circuits in a material object, in interneural connections, again, material objects, in neural parameters, for example, some capacitances of a neural membrane, or alternatively in the spiking patterns of individual neurons. So they are talking about some physical manifestations of memories. And there is no unique theory of memory. It is a huge open question in neuroscience. However, the vector field unites all of that. And if it would actually make all of these hypotheses true at the same time. So there is plenty of indirect evidence, and I would like to summarize. How can vector field, mathematical idea, help understand the idea of the mind? If we allow ourselves to hypothesize that a simplified technical proxy for the mind is actually the velocity vector field of the brain, as a starting point, I emphasize it's not the full answer, but as a starting point, then what? This vector field could be reconstructed from detailed brain data. If we know everything about the brain, and of course we don't know everything about the brain now, but there are big brain projects working in Europe and America whose goal is basically that, to try to measure various brain parameters and to construct models of the brain. And their models, by the way, are in the form of dynamical systems. If this is the case, then we could measure the mind, and the mind could become the subject of proper natural science, such as physics, for example, or chemistry. And then we could unite psychology and neuroscience into a single discipline. And my final remark is that the brain changes with time. Its vector field is changing with time. We know that the human personality changes with time. So the mind does change with time. So we can regard the mind as a process occurring with time. Thank you very much. And this is the end of my talk.
Thank you, Natalia. Thank you so much. Yeah, you're wonderful. We have quite a discussion going here. You're so wonderful that as we were at home, and my wife took the liberty of listening to some of that, and you are invited to dinner, I'm to tell you. So when circumstances allow. So we have a huge debate here, and I've got actually the impossible job now, where basically we have some of the biggest questions of humankind and about 10 minutes. So I think possibly where we could start with just a number of observations which has kind of been recurring in the discussion about boundary problems, you know, as to, in a sense, what do we declare is the mind, and in a sense, you know, where do we cut off the brain from the body, for example, or what do we define as the mind, the single individual, or the society, which after all seems to conform to your idea of the vector field interacting with each other. Perhaps I could just invite you to have a comment on the kind of the boundary issues here.
Well, it is a little bit difficult to speak about boundaries because, as we all know, there are volumes written, maybe not volumes, thousands of volumes written about the mind. There are tons of papers, maybe even millions of papers written about the mind. And the problem is that the mind is such a multifaceted phenomenon. And what we can single out, what people have been trying to single out, particularly psychologists and also philosophers, is where the recurrent features of the mind. What would be the mind attributes? And some of them are already specified, and it is impossible to specify all of them, because the challenge here is that they are all kind of hand waving, very vague, and they're expressed in a vague language which is not mathematical. And when I was reading some of these philosophical books, I was very much impressed, because I'm very sorry to say, I apologize, because I know philosophers has a hugely difficult problem in front of them. But basically, I was looking for any specific details. Could you give me a clue? I couldn't find any. And the only clues I found, which were basically practically useful, were the ones which I mentioned. Because what is the mind? Well, the mind is some entity. We don't know what it is, but we know that this entity is somehow related to our intelligence, to how we think. Also, we know that the mind controls our body, our behavior. The mind is what does decision making, what decides for us. And also we know from psychology that the mind evolves, because of course the mind is linked to our personality, and most obviously our personalities evolves with time. So I just saw my task as a mathematician, as a scientist, actually, first of all, as collecting all the facts which we know about the mind and about the brain, which could help us, which could be practically helpful in identifying this culprit, this suspect, because I wanted a definition, because without a definition, we can't do anything in science. We need a definition of something which we can measure. And I just like this analogy with the theory of electricity. We knew about electricity for several thousands of years, thousands. People knew electricity is when you stroke a cat and some sparks appear, or when you rub an amber stick and it affects, say, or dust or something like this. But nobody knew what is electricity. And then somebody came up with the idea that electricity is huge. I have no idea what it is, and I will not know, not in my lifetime. But one key aspect of electricity is first of all the existence of a charged particle, and then many of such particles can move together and create an electrical current, and then this thing can be measured. So that was only a starting point, and we know that electricity is basically everything which surrounds us. And Alex Zagoskin is obviously an expert in a very modern aspect of electricity, quantum theory, which was obviously not even known in the 19th century. But we need some very pragmatic, very practical starting point. So that was my kind of starting point. And I would like to emphasize that by no means, I think, that the velocity vector field is ready to answer the question of consciousness, because obviously everybody wants to know what consciousness is, what self-awareness is. I confess, well, openly, that I have no idea, not even a clue. Well, I have some clue, I have some ideas, but these are just as good as those by numerous other people who have no mathematical evidence, who have no scientific evidence. So yes, the boundary conditions are those which are specified. Everything else is basically speculation. And then you see only a limited set of boundary conditions was sufficient for me to approach the idea of a vector field, of a self-organizing vector field as a mind candidate. But plenty of indirect evidence, which most of it I did not even mention now, but there's plenty of literature which I then examined, which told me that, you see, that was actually a good guess, because this bit fits in the picture, this bit fits in the picture. And so if the vector field of the brain as a mathematical object can form a skeleton, the skeleton of our understanding of the brain theory, then all parts, all experimental evidence, all new facts about the brain mechanisms, they could complement the general picture by filling in the gaps. but around a skeleton. So what I'm proposing essentially would be a skeleton as the beginning. So I don't know if I answered your question.
I can see the elegance. Certainly, it's totally fascinating. I think we'll just invite colleagues here. So thank you very much for this chat, which is wonderful.
There's perhaps,
the
Peter,
discussion. Yes.
Sorry, there's perhaps a question that is related to what has just been said that could help wrapping up. It's just come up.
Right.
And it's,
Yes.
how have you been able to tackle the issue of generating this self-governing vector field model? Once this module can be created, do you see this rapidly advancing AI and reducing the importance of the role of the human mind in decision making?
Thank you very much. This is a brilliant question. Of course, artificial intelligence is also a huge, big part of this research. And of course, I had no time to speak about it. So thank you for giving me the opportunity to answer. Yes, if the velocity vector field, which is plastic and self-organizing, can be viewed as a candidate for the intelligence paradigm, then we can assume that we don't need the brain, we don't need the neural network to construct a plastic device, a self-organizing device. A plastic self-organizing device can be constructed out of very different components, not necessarily neurons. It could be maybe some liquid architecture with internal connections, which they speak about in, for example, Terminator movie. If you remember this liquid robot, which was self-organizing its architecture, restoring its architecture. It could be something which is yet unknown in modern science and modern physics or chemistry. But if we can implement the principle, maybe this could be a good way to create artificial intelligence machines. I can say more. I can actually say more than that. If I'm allowed to, but that would be a pure speculation and a projection, I guess, really, like science fiction writers are doing. In principle, if in 50 years' time we are able to construct a realistic model of the brain, and if we will measure the velocity vector field of the brain as a single hugely complicated object, but suppose we have it, then we will be able to explain why it makes mistakes. Right? Because we know we make mistakes. It is imperfect. Our decision making is hugely imperfect. We are full of flaws. Our brains are so bad in a sense. It's a miracle that we make good decisions. And we are unable to process big amounts of information. That's our huge flaw, by the way. Another flaw. But suppose we identify why this is happening. Then perhaps we would propose how to create a device without these flaws. We could improve on the velocity vector field on the brain, and we could create an artificial device which thinks like the brain but does not make mistakes and can operate with much bigger memory, and then it will be able to process much bigger amounts of information in the way that humans do without mistakes. So in theory it should be superintelligence, what we call superintelligence. And of course, this is the future, which I probably wouldn't want for myself, but I am quite confident we will not live to this. And this will not happen too soon, because even to understand the brain, can you imagine, we need to be able to get access to every single brain cell non-invasively without drilling inside, because we don't want to destroy the living brain. We have to get access to every single cell inside without destroying it. This is currently absolutely beyond the capacities, the capabilities of modern science. So in a sense, we can speculate about it, and this future we will not see, at least. So we are kind of safe at the moment. So I don't know if I answered your question, but I was trying my best. Thank you very much for it.
Wonderful discussion by any standards. I'm going to be mean, and I'm going to insist on the pendulum of the clock, and therefore perhaps we can come back to some things later if we get lucky with those things, or refer backwards. And also we can keep a copy of the chat, which is really quite interesting. Natalia, you've not had a chance to see it properly, but we can keep a copy of that chat and maybe find some way of utilizing it at some point. But we have Jason von Medding from the Florida Institute for Built Environment resilience. And we have his podcast colleague and our campus colleague, Ksenia Jumutina, and I think that they are just about ready to take over our screens, and we'll be discussing another dimension. I think really we will go in a very different direction with this one. So Jason, are you ready?
I'm ready. Thanks, Peter.
Thanks, Peter.
Ksenia, you're ready as well, so I'm going to
We are ready.
Sign off and listen.
All right.
Thank you.
Yeah, ready to play, Jason? All set?
Yes.
Cool. Great. Okay, well, let's chat. So, hi, everyone. I think some of you know me. I'm Ksenia Jumutina. I'm a senior lecturer in sustainable and resilient urbanism here at Loughborough University, and I'm also deputy lead for the Secure and Resilient Societies Challenge. And, you know, when I don't do academic work, I kind of always do academic work. I get to chat to Jason a lot. You know, we write a lot together, and we have a podcast called Disasters Deconstructed. And I think we sort of became friends because we really wanted to unpack and explore the ideas of, you know, what is disaster. And I think we also realized that actually we're unpacking these ideas best when we talk, when we converse. And so we thought that, well, we may as well kind of replicate the conversations that we usually have. And, you know, we have a lot of conversations and maybe reflect on them somehow. And through this means of conversation, engage you in a dialogue about disasters. And so we've decided to skip the presentation and just go for an interview, as we do in the podcast. So we love chatting, basically. So Jason, I'm just going to ask you lots of fascinating questions, right? I mean, hardly a day goes by that we don't see something about disasters, right? There is always a mention. And I think with COVID in particular, there is just so much information about disasters that sometimes perhaps people don't even pay attention to this anymore. But I think this sort of disaster overload has happened in the last 20 years, you know? So what is happening? Is disaster a new phenomena? And what is a disaster?
Well, thank you, first of all, for the invitation. Thank you to IAS and to Loughborough for hosting this event. It's just a fascinating thing to be involved in. Yes, the disasters are not just about hazards, and that's a good starting point, I think, for this conversation, because often when we think of how we hear about disasters in the media, or how we talk about them in our social groups, often we are focusing on the earthquake or the flood or the tsunami, right? We're focusing on the hazard phenomenon. Mm-hmm. The other thing is they're also not events. So we have this other way of framing disaster, which is very event focused. So a disaster, we talk about it like Hurricane Katrina as a disaster, as something that occurred in a very specific short period of time, right? And the interesting thing is that as we have gone through the last 12 months of a global pandemic, we've seen a lot of people start to shift the way they're thinking of a disaster as a more drawn out process over time, because of the nature of COVID. So I think this is a great place to start, because you and I, when we talk about disasters, we are talking about disasters as processes over time. And we're often, with our guests on the podcast and just in our writing and more generally just random discussions, talking about the temporal aspect of disasters, right? And of how risk is created over time. Mm-hmm. So in preparing to engage in this session, I've been reflecting on this temporal dimension in particular. And so for me, with my background in architecture and construction management, the kind of predominant thing that I think about generally in my, with my colleagues in my school is like a spatial dimension of disaster, and mm-hmm. where risk is created and how risk is created and manifested spatially. But I think this temporal dimension is so critical to our understanding, especially when we bring in people into the equation, not just the built environment. We bring in people and we think about how risk is created through vulnerabilities, human vulnerabilities. And so history is important for me. And I'm so excited about this conversation because we can start to talk about a kind of materialist conception of history. And so the famous recipe for disaster that we know from our literature is that when you mix together the hazard that occurs, right, the earthquake, tornado, flood, whatever, the vulnerable people that encounter that hazard. So of course, everybody is vulnerable to some degree just by virtue of their being human. And we will talk, this will come up, I think, in our conversation, you know, how vulnerability is so uneven. And then exposure as well. So based on where and how people live. And finally, something that's come up in the literature a lot more recently is about the capacity. So to what degree are individuals and communities actually able to mobilize around their shared resources and cope with risk? And I think of all these aspects of disaster as like ingredients. And so in many cases, something is missing in our analysis. And so when people use those ingredients, they sometimes fall into this trap of having an event or hazard-centric framing of disaster. And so, you know, like when you make a Christmas dinner, there's some special ingredients, right, that you can't omit.
Right.
So for me, like that's what time is. And so time is like the historical record of injustice. Yeah. It's like the cranberry sauce of the disaster equation, you know?
I love it. Yeah, great.
So I'd like to contend today that disasters, and often in our field, we refer to risk, disaster risk, is created within the context of complex and ever-changing culture and society. And I'd like to kind of pull that thread today. And so disaster studies is very interdisciplinary. And a seminal contribution I want to point out was from Anthony Oliver Smith, which is related to this temporal aspect, and I think it has been very influential for our field. And so he looked at the creation over time of material conditions for the devastating 1970 earthquake in Peru. And so looking at the way that Spanish colonizers undermined the indigenous disaster risk adaptation measures, he positioned this so-called event in 1970 as a 500-year earthquake. And so he kind of started that conversation about a really long period of time of risk creation. And we've seen a wide emergence of scholarship following that sort of argument and looking at what we call root causes of disasters. So what's really causing the disaster? And that's kind of where we position our conversations in the podcast, that risk is often located deep in the history of a place. And so it's key to any work that we're doing to understand what's going on when an earthquake occurs or when a flood occurs.
Yeah, but okay, so let's talk about time a little bit more. I think the question that you and I and many of our colleagues ask our students, right, very often is that, so when does a disaster start? If it's not an event, right? If it's not kind of boom, unexpected, and it's gone, when does it start? How far do we need to travel in time to actually see its origin if we argue that disaster is a process?
So I think we need to look, I mean, it depends on the place, is what I would start by saying. Depends on the place and how that society has developed. Often in my work, I often focus on inequalities and injustices in society and oppressive systems, and broadly on the social system. And so, of course, this looks different in different places and different geographies and different societies. And so I think that this kind of discriminatory risk is often decades old, often centuries old. And so we have to be kind of context sensitive when we're talking about like where does a disaster start. But I think it's critical to look at a specific community, like right down to the local level. And of course, there's individual components to this. There's individual identities that experience risk differently as well. But at a community level too, there's groups that experience these discriminatory aspects of their social system. And so that's where we need to start. And we need to look back and say, where did these root causes really start to manifest in the society, in the way that the society developed, and then chart that over time. So I would say, I mean, I often say disasters are discriminate, and it's kind of like in a provocative way to get people think like, well, the disaster is not making a choice to discriminate here, right? It's about people making those choices to make those decisions in the first place, but also to uphold the injustice of parts of the social system. And so I think the historical record, when we really look at it, demonstrates that disasters are long-term processes. And the problem that we have is that we are often very quick to respond with technical solutions to this without really getting to the root causes. And so we see a lot of talk about risk reduction and capacity building and resilience building, adaptation, and so on. But the temporal imperative of actually addressing the root causes is it requires more systemic change, right? And so I don't think that's a comfortable solution because it's challenging for those in power. And so we really need to get outside of this end of history bubble that I'm sure many people will recognize that in many disciplines. And as researchers, practitioners, and policymakers, we need to leave the capsule if you dare, to quote a David Bowie lyric.
Yeah, I mean, it's just so important, right? Yet we don't talk about it because hazards take over, right? Hazard is what kind of predominant, and it's a comfortable conversation. Like, it's comfortable to talk about hazard. It's not very comfortable to talk about colonization, imperialism. It's not comfortable to talk about violence, right? It's not comfortable to talk about politics of disasters because they're seen as apolitical and sudden, right? But I think that became really, really prominent in a way that we see the whole process of risk creation is through the kind of work of Blakey and Wisner and Cannon, right? And at risk, I'm sure all of us disaster scholars who work in the space would recognize that title. Yet we know that these ideas of root causes and the element of vulnerability that comes with this is somewhat problematic, right? Because whilst we're arguing that vulnerability is the condition that, or the element that turns hazards into a disaster, we also very often are very quick to kind of to decide who is vulnerable, right? Or like the poor, or the women, or the disabled people, right? And we hardly ever think intersectionally about this as well. But I want to talk to you about vulnerability because I know that you have some strong opinions on a matter. So who is vulnerable and what's vulnerability?
Well, I do have opinions on this. And I think the way that we talk about vulnerability in the disaster study space is we have what we call the vulnerability paradigm. And so we often people think that the critical perspective on disasters is to adopt the vulnerability paradigm. And they didn't think that they're doing something radical by saying that they adopt that paradigm, as opposed to the hazard paradigm, and the focus on hazards as the cause of a disaster. But there's a lack of nuance sometimes in the adoption of the vulnerability paradigm, because as many authors have pointed out, it can be a very Orientalist approach to studying disasters, and can be kind of paternalistic and frame communities experiencing risk as the other that needs our help, right? And you have these kind of paternalistic approaches that are, as Freire would say, more humanitarian than humanist. And so I think looking at vulnerability outside of disaster studies has been something really important for my own thinking, and looking at feminist framings of vulnerability, and that look more at vulnerability as a condition of possibility, and as something that's like naturally part of our humanity. And actually it's somewhere where we can really challenge injustice, not in trying to say like these poor vulnerable people need help and throw some money at them, but by saying we need to share in the vulnerability of the oppressed and actually act in solidarity to challenge that oppression and violence. And so is vulnerability naturally occurring? I believe it's part of our condition. But I certainly distressed by some of the ways in which it's used, so in such a blasé way. And the oppression, the oppressive part of vulnerability is not naturally occurring, and that's where the injustice is, right? And so think of like poverty, for instance, which is a very resilient phenomena, right? And it's often framed as a cause of war or crime or psychological distress. But I would posit that it's only a symptom of a social system that's not really functioning properly to ensure public health. And so if you look at that in the US, for instance, poverty is so intimately related to the for-profit prison system, right? And so incarceration is used as a remedy for poverty. But this is really looking at things in completely the wrong way, and it's tragic, and I would argue also is quite cynical, and it's a misdiagnosis of what the root cause is of crime or whatnot. So we need to think about systems and structures and the violence of the status quo. Often in many societies, we need to look beyond disaster studies to other fields for analysis. And so in this example of the prison system, we look to work on abolition, and we look to the arguments around how communities organize against the carceral system. And we often see that they have the same focus on root causes, and we can learn so much from those other fields of practice and research and organizing as we look at how disasters occur as processes as well.
Right. And let's keep talking about vulnerability. I like this topic, right? So you've explained why it's contested, right? You've explained that it's used so widely in disaster studies, nevertheless. But let's talk a little bit more about underlying meanings. I guess there are two things to this, right? The first is that, well, the recent work that we've done with translation, we've seen that vulnerability, it does translate, but it translates as weakness. So immediately when we call somebody vulnerable, right, we call them weak. And it's us who decide that they're weak, right, whether we actually know the situation. And then secondly, and related to that work, is that vulnerability is somehow seen as an opposite of resilience, right? So vulnerability is bad and resilience is great. So once we remove your vulnerability, you all of a sudden become resilient, but which is of course not the case, because to remove vulnerability, you need to remove root causes, as you've just been explaining, whereas what we kind of call resilience is in fact kind of enhancing capacities and hardly ever removing the actual root causes. So what is the problem with the underlying meanings and labeling? How should we use this word? Should we use these words at all? Are they useful for the way that we communicate disaster risk creation and disaster risk reduction?
Yeah, that's really at the core of a lot of work that we've been doing over the past few years, with a focus on the importance of narrative and the importance on words, not just to get into arguments about what words mean necessarily, but just to actually do research that shows the impact of the way that we frame things and the way that we use language, and the impact of different ways of translating, and so just to like pick up on some of those things that I've been working on. It comes from a foundation where we are trying to recognize that like politicians and policymakers are often operating in a very safe kind of, or trying to look for a safe positioning of their rhetoric or of their policy. And so that often means framing things as like naturally occurring, or it's nobody's fault. So this idea of whose fault is, who is to blame, is extremely important. And so that's kind of opposed to a analysis of disasters, which is rooted in this relationship between the oppressor and the oppressed, and challenges this idea that any of these phenomena are naturally occurring. And so I think in the work that I've been doing, when we talk about the meaning of words across languages and in different domains, like in the public domain and in policy and in the media, we just see huge differentials, and we see like dominant language emerge, which kind of captures the space, and then that filters right down into populations. So like the most common one that we talk about often is natural disaster, and which for me, it's not all about just like changing the language. It's about the overall framing. And as we've discussed already, I think everybody can recognize where we're coming from when we contest that disasters should be called natural. And so, but where I live in the US, that's like completely the dominant framing, right, is naturalness, and the focus on the hurricane that just happened, and that's to blame, right? And there's not a deeper analysis of why people are so unequally vulnerable. And then when we go into other languages, like we've been doing recently in some translation work, we just see that we also have this dominance of English and an almost quasi-imperialist like imposition of our Western ideas through language. And so that's been really interesting, just to look at different power imbalances between countries, between researchers and the people who actually, I mean, sometimes researchers experience disasters, but often we are approaching communities experiencing risk as objects, and we never really get around to seeing their agency, like relinquishing our position of like power in that relationship, and struggling with them to create a better future.
Right, and I think that better futures, it's kind of a lovely segue to my next question, in that we know that disasters create opportunities, right? Because very often the systems that are in place, and I'm not just talking about physical systems, but societal systems, are, they're disturbed, right? So there is a great opportunity for a change. And so I suppose the last 30 years of disaster risk reduction, or 20 years of disaster risk reduction, have been going under the banner of Build Back Better, right? And well, my opinion on that, in that it's a very much liberal tool, right? It literally have become a slogan rather than a call for action. Because what we do is that instead of building back better, we're building back faster, we're building back cheaper, or we are building back better for very few who were quite well off before a disaster. So what we're doing is we are reestablishing the status quo. But also what you're saying is that we know why disasters happen. We know we have enough physical science to deal with hazards, right? And to understand hazards. We also have enough understanding of the structural root causes and kind of economic systems that bring and enhance those root causes. So we can, if we look at the recipe of disasters, as you brought it at the beginning, right? We have all the ingredients to actually address it. So why aren't we addressing risks then? Why are we still having disasters?
So I think that a lot of this is to do with power, and it's something that not that many people in the disaster field talk about, and certainly practitioners are unlikely for various reasons to really go deep into that kind of analysis, and politicians as well, and intergovernmental agencies are very unlikely to go there. And so a lot of this, I think, is about the fact that funding and politics and like those relationships between powerful actors all carry an agenda to reinforce and recreate the status quo conditions. And so that leads to technocratic solutions and a kind of avoidance of really dealing with any sort of root cause of risk. And so, yeah, I would say we just have so much responsibility as scholars to actually work with communities and start to create a more take back power with communities to control their own destiny and to listen to how people actually experience this material creation of risk and have that as a starting point for our analysis rather than coming in with these elite theories about what is going on for them and then imposing our solution on them. And so I think technical solutions are bound to fail, and because we are so focused on that and our funding for research and for practice is so directed towards technical solutions, they will fail, not because we're necessarily selfish, like Garrett Hardin famously argued, but I don't think we need to privatize the commons. We don't need to protect ourselves from each other. And that's the wrong position to take. There are certainly people who oppress in society, there's systems of oppression, but I personally, and I'm sure people disagree with me, people always disagree with me, but I personally believe that people are inherently inclined to be to act in solidarity and to be empathetic. And I think most people want good things for others, but we are also we also live within societies which maybe don't promote those values. And so we sometimes have to battle to reclaim our humanity, I think, within a society that values sometimes individualism and competition with others. So yeah, that's kind of my thoughts on what is going wrong and why disasters keep happening. I think we just haven't yet really reclaimed our full humanity.
Yeah, I agree with you on that. I also think that perhaps we need kind of talk a little bit more about solidarity, right, in disaster studies, because we don't really. It's a new conversation that is evolving now. I think we also should never forget that everybody has capacities, right? There isn't one person, no matter how oppressed, that doesn't have their own knowledges and their own kind of skills, right, that they can bring to the table. And very often we just don't appreciate it or don't respect that just because we come from the global north. But I think the problem with studying disasters or talking about disasters is that we very often end up in this really dark place, right, where everything is just bad and it's just bad. So is there hope, or is this the end?
I really think there is hope. And when we think of how risk is so linked to this temporal kind of component, and that's where we really see risk developing and then turning into a disaster. I think there's a lot of hope, and we can look back through the historical record at like more people's history than history of the powerful, and we can see over that record, we can see so many people coming together to reclaim their full humanity and to organize together to oppose injustice. And so like that always gives me hope. I think we need to have more political engagement from below, and that's not with an objective of voting for the right one of two parties, that as we so often see, but something much deeper and more locally engaged. And we need a more liberatory process of reflective thinking and doing. How do we actually engage with people experiencing risk so we're not operating from this position of distance where we can misdiagnose what's going on in their experience? And different ways of approaching research are so important. We saw now 2 years ago, but the Disaster Studies Manifesto, which really outlined a different way for engaging in research in the disaster study space, which I think was challenging a lot of these injustices and power differentials that I've talked about today. And yet, like different methodologies, it goes right back to our kind of research philosophies and how we actually develop a research process which is genuinely engaged, not just as a tick box exercise of engaging with the vulnerable community, but as an intentional way of developing solidarity with people and to create research processes with people and so that they become subjects rather than objects. So I see a lot of hope, and certainly in working in this space and seeing the way that disaster studies is developing and the voices that are coming to the fore with really great analyses makes me very hopeful. And of course, the communities that are organizing against these unjust material conditions are amazing, and we should be working more with them.
We should. Thanks so much. I think, it was fascinating. I never tired of talking about disasters with you in particular. So I think I'll pass over to Peter, and I'll leave you to answer all the difficult questions.
Oh, thanks.
Sounds like you're on your own, Jason.
Yeah.
Wonderful. Again, so, thank you both so much. It's extremely interesting. And again, we've got the conversation going. I would also invite all of us here on the call, if anyone wants to turn on the camera, ask a question verbally, we have time to accommodate some questions in that way. So please feel free. It would be nice to see you. So I think perhaps I think there's a number of different threads going on, but let me pick one that's interesting, I think, which is about power. Yeah, so in a sense, are you giving us a kind of temporal definition of power, which is to say that the absence of power is loss of control of causes, if you put it like that, and the presence of power must be in a sense the ability to manage one's own root causes. Can you see where I'm going with the logic of that? That there's a kind of temporal relation to power here, and I think is that what's being expressed here?
I think that's a good way to look at it. And in a lot of our work, we're arguing for more localized power for sure, and for I believe that all people have power, and sometimes it's a case of reclaiming what is yours, and so the relationship of the individual to the wider community and the state is in question here. And I think the more that or people experiencing these material conditions of risk creation are that power is kind of taken away from them, and that control is taken away from them. They're often just left to sink or swim. And so, in a society like the US, when I talk to a lot of my students about this, it's almost ingrained in the mythology of the country, this kind of narrative of heroic individuals, and the idea that you need to just cultivate your own personal resilience, and then that will make you like a good person, and you'll be able to cope with any sort of challenge that comes your way. And so, and that's so embedded in a society. And I think politicians and policymakers often reinforce this through policy, which is like focusing on individual self-improvement as a way to deal with risk that you might face. And I think that's, broadly speaking, or Ksenia mentioned this earlier, it kind of fits really nicely into a neoliberal sort of approach to governance.
Wonderful, thank you.
Peter, we have a very interesting question from Marsha, which is also connected to previous comments about disasters and velocity. Sometimes if they happen slowly, they're not recognized as such. So Marsha asks, how does power affect the temporality of disasters? Does a disaster start or end when an expert says it has, or when the community experiencing it has?
Yeah, I love this question. So, I mean, you might imagine I'm going to say, well, it's definitely not when the expert says that it ends. We should be working with communities to really understand that experience better, because we're so often removed from the experience. And so what we see usually in literature is a very expert framing of like what the disaster is and when it started and when it ended. So even if we develop an analysis of a disaster over a long period, like say we develop a 200-year analysis of a disaster in a certain country where we have not experienced the way that risk has developed, and we haven't undertaken the types of research that would actually develop a robust record of that, then that is locally contextualized in the experience of people that experience it, then I think we are definitely falling into a trap of defining something for others, and that's a big risk that we take as scholars, So I think we just need to work in different ways and recognize our ignorance often.
Thank you so much. There's a couple of more interesting definitional questions here. If I take the one from Vanika, I hope I pronounced it right, but interesting take on when disasters start, but when do disasters end? For instance, on Nepal, are we still in 1934, earthquake aftermath, or 2015, or the cumulative of both, or the overlap?
Yeah, that's a great question, and I like the way you're thinking there. And so, I would say that our disasters never really end if we look at them as processes in time, and it's probably more accurate to say that it's a cumulative process over time in certain places where they accumulate and multiply and often just run on into the next disaster. And there's a lot of work in our field looking at even things which aren't really called disasters and just everyday precarity. And I think that also connects some of these things that we might frame as like big events located in a short time frame. We do see that certainly everyday precarity connects these events in certain populations. And often we see that communities and individuals are much more concerned about everyday precarity than they are about the possibility of a big event.
Yeah, fascinating. Frank was asking about the definition of crisis. Given that we have different descriptions of disaster, where do we position crisis in the discourse?
So there's not really any agreement about definitions in our field. So you'll get lots of different definitions for disaster and crisis and hazard and so on. Generally, it's kind of accepted that we're talking about orders of magnitude. So a crisis, an emergency, and a disaster and a catastrophe are kind of ramping up to the magnitude of what we're discussing. And some people define that by the number of deaths, and that's kind of a common way to look at it.
I was wondering, actually, following the logic of your presentation and the logic of our event, also if crisis was some sort of political suspension of time when power becomes uncertain, perhaps prior to or after an accepted disaster. So it's kind of a temporal suspension.
Yeah, I like that a lot. I suppose it's much more broadly used in a different way than referring to the kind of disaster paradigm. in a political context, and that's really interesting. I haven't really considered that.
Yeah, and I think Alexander has been stirring the discussion quite interestingly with the kind of the impossibility of an absence of risk, in a sense. It's indeed to consider or to prepare for a life or a situation of no risk is a very dangerous thing to do.
Yeah, no, that's great. And I wrote a paper or more an article for a public audience around near the beginning of COVID, and I was reflecting on the position that world leaders were taking to risk, and it was very much a position of anti-vulnerability, like we are not vulnerable, and so and we see this as well in the resilience discourses of trying to build resilience to the point where we have no risk, and it's just not possible. And it's masculinist, and it's I think it's largely ignorant of the reality of the human condition.
Again,
I would like, if I may.
Sorry, Alexander.
If I may, just one word. The game theory shows that if you want to minimize the results of a loss, this is a completely different problem from the problem of maximizing the results of a win. So they are two different problems. They have two different solutions. And I'm afraid that if you are trying to minimize the chances of any problem, minimize the current risks, you're inevitably running into big risks in the future, not in the last place, because you are never actually ready to act in case of an emergency. Mm-hmm. And I believe that every large enough organization which looks for its current good standing, its current good, audit and everything, will inevitably tend to try and eliminate current risks, whatever the future price. They will have very short horizon of prediction, and this is a systemic problem. It's not somebody else's, some person's fault. This is how the things are being set up.
Yeah, thank you for that. That's a great contribution. I feel that when I think of this kind of move to try to be invulnerable, there's just so many problems with that, and it sets us against each other, and it causes people to make decisions which oppress others. And I certainly reflected on that when I was talking about political leaders trying to posture as invulnerable in relation to COVID. And when I think of vulnerability, I think of a condition which is has so much potential for us to develop our interconnection with others and with all life on the planet, and to be more sensitive to the impact of our decisions in that way, with that knowledge that we're part of this interrelated existence, and what we do and really affects other people.
Jason, there's a question related to social media, I believe. The more integrated and connected we become, does that magnify the disaster? By Andy. By moving to decentralization, does that give us the opportunity to be more agile and therefore more resilient?
I would say yes, and we see a lot of examples of communities that are organizing using the incredible capabilities that we now have and the connectedness technologically that we enjoy now. Of course, there's also risks associated that are being created through our implementation of innovations. And so I guess it's about how we use those new opportunities for connectedness. I think if we use them in healthy ways, they just have incredible potential to act together to address some of the underlying social systemic problems that we face.
Can I say the COVID word to you? And are we now, in a sense, is this entirely consistent, isn't it, with what you've been saying, to argue that perhaps the different exposure of different communities, COVID, and its ill effects is maybe revealing root causes embedded in time, power relations?
Yeah, I think I was discussing this yesterday with one of my classes about just the stark differences we see across, when we compare countries, how they've responded politically, how different social systems, if we want to use that term, have different ways of dealing with these kind of risks, and the degree of freedom and individualism definitely plays a part, and like the expectations of people within that society of what their leaders will do or are kind of all being challenged. And I think that there's going to be a lot of work coming out in the future about how different social systems responded to COVID, and it's so interesting. I was talking yesterday with my class about just comparing a place like Vietnam and the US, and you're comparing like 400,000 deaths to 30, and but very different social systems and with different economic kind of foundations and cultural characteristics. So it's a really interesting way to think about risk, and it kind of reinforces this idea that risk is really part of that broader consideration of the social system.
So I'm going to take one more just because he's on next. But if we come back to the point of crisis, then David is bringing in the temporal relation here, because crisis is when events arrive at such a rate as to threaten to overwhelm normal decision making. So that gives us quite a nice definition, I think, on that point. I think.
Yeah, no, that's great, and it definitely is similar to many definitions of disaster that are out there as well. It's disasters as overwhelming the capacity of a community to respond to an event. And most definitions of disasters are not like what I've described today. Most definitions of disasters are event specific.
Jason, wonderful. Thank you so much. All the way from Florida. Ksenia, thank you so much. That was inspiring and thought-provoking, and very, very, very much appreciated. So
thank you. Thanks, everybody.
Thank you. Please stay, and we'll move on to David next. We're going to talk about spy time, and no better to talk about it than David Omand. Just reading this, first UK Security and Intelligence Coordinator. That's only reading it because to remember 4 words is getting harder and harder. And former director of GCHQ, these days professor at King's College London. David, we are so happy to have you here, and it's over to you when you're ready.
Right. I hope you can hear me.
Perfectly so.
Good.
Perfectly so.
Thanks, Peter. And thanks for the invitation to join in this event on time, because what it did was force me to examine intelligence activity, a subject I teach at King's, examine intelligence activity through the lens of time. In fact, what I'm going to do is to examine it through 4 lenses of time, because the word time carries several meanings for intelligence officers, as I suspect it does for all of us. It's the objective measure of the duration of the interval between events. It's the subjective experience of such time intervals. You can label a proper time associated with a location in space, space-time, and you can analyze as a sequence of events to which Bayesian inference can be applied to relate effects back to causes. So I want to look at intelligence activity through those four lenses of time. And I'll start with duration of time, because not enough time has been a problematic issue for spies, for the case officers who control them, and for the customers for their intelligence reports. So to start with the definition, I would, or not, yes, a definition. I would say the primary purpose of intelligence is to improve the quality of decision making. If you like, that's an approach an evolutionary biologist might take. And the case of secret intelligence is where you achieve that using information that others have gone to great lengths to try and keep from you. By definition, you have to overcome the will of the other who has the secret in order for you to acquire it. The timeliness of that information you get from the person with the secret, the dictator, the terrorist, the proliferator, the people smuggler, the timeliness of that information is of the utmost importance. And when you look back, you can see that one way of explaining what's been going on over the last few hundred years has been the search for technologies that can act as chronophages or time eaters. Chronophage, I should say, is a lovely word. It's coined by the engineer John Taylor, who designed the wonderful clock in my old Cambridge College Corpus Christi, where I'm an honorary fellow. And the escapement on the top of the clock is a large grasshopper whose jaws move to munch out intervals of time, so chronophage. You need to, if in the intelligence world, communicate the intelligence requirements. You need to speed up the collection. You need to get it back to the analysts. You shorten the time for processing and analysis. And finally, as quickly as possible, you've got to get the results to the final users of intelligence. And there's clear advantage in reducing those time durations and making more effective use of what time is available. So to pick a classic example, you have the wartime MI6 agent in the roof space of a hut in a remote Norwegian farmhouse, huddled over a covert transmitter trying to establish radio contact with London to pass on news of the movement of the battleship Tirpitz in the short space of time before German direction-finding equipment could locate him. And you can imagine the tension in the operations room of the old Admiralty building in Whitehall, waiting for that intelligence on the German battleship, knowing that if the battleship had left Ford, a fateful decision to scatter the ships sailing on a dangerous Arctic convoy would have to be taken. And when you think about that, any intelligence report can be thought of as having two time duration associated parameters. You could call latency and perishability. And latency refers to the freshness of the intelligence, the time delay between the content of the information contained in a report. You can imagine a sort of virtual date time stamp being put on the information and its final availability for exploitation. So latency includes the time taken to acquire, to transmit back to by whatever means, and to process, including cryptanalysis and traffic analysis and transcription and translation. And when you think about it, you've got subsequent developments. If you take that simple problem of direction finding, subsequent developments have seen the use of mobile detection vans, of aircraft, satellites to detect and triangulate radio transmissions. Even in the early Cold War, covert monitoring of electromagnetic emissions from the Soviet embassy in London to detect the resonance when receivers were tuned to the frequency used by the Soviet agents in the UK. But then on the other side of the ledger, you've got the development of burst transmitters to compress the signal, to shorten the time on air. You've got frequency hopping to make detection of new transmissions harder. And today, of course, in the digital world, you can hide messages and otherwise innocent looking websites to provide communication at the speed of the internet. And comparable arms races have pitted the efforts of cryptologists seeking to construct ciphers to keep secrets secret for longer against those of cryptanalysts developing ways of defeating them, including the application of advanced mathematics. We know that the pressure of doing this in war led ultimately to the programmable computer and indeed to the supercomputers of the Cold War, as well as a range of shortcuts from recruiting cipher clerks as agents to bugging cipher rooms. Perishability is a subtly different idea. It refers to the length of time that by which the compromise of the content of a message would cause significant damage to national security. A great deal of tactical information is sensitive for only a very short time, for example, in a moving battle, before the units move in response to the ebb and flow of conflict. Criminals can get away with only the protection provided by their normal encryption on a mobile device or by using burner phones, if all they're worried about is the timing of a narcotic shipment or a one-off meeting. So this is where security classifications come from, because they're a measure of that perishability. You have to take a decision, a judgment, over the degree of security needed to prevent compromise, depending on the perishability of the information. Most knowledge of intelligent techniques, as against content of individual messages, has low perishability. So it lasts for a long time, that sensitivity. In Bletchley Park, the staff were sworn to lifelong secrecy, a code of omerta that lasted until the 1970s. Some content has low perishability. The classic example there was Venona, Soviet intelligence communications encrypted with one-time pads. The messages were intercepted and stored by the United States and the United Kingdom from 1943 onwards, although there was no way you could read them. But the Soviet Union made a significant error under the pressure of war, and they issued the same one-time pads for different links between Moscow Center and the overseas residencies in embassies overseas running intelligence operations. And over years of effort, fragments of the content of those old messages could therefore be recovered. That's how Donald Maclean, the head of Chancellery in the British Embassy, was uncovered as a KGB agent, or predecessor NKVD agent, and the atom spy Klaus Fuchs. You've got another example of low perishability from the fragmentary notes on KGB case files smuggled out of the Soviet Union by the defecting KGB archivist, Major Vasily Mitrokhin. Those notes on the files had low perishability, since eventually they allowed important questions about past operations to be answered definitively. Today, internet user interactions, collected in bulk and stored, can be used as a form of backwards time machine. You keep the data, you conserve potential intelligence and evidential value for the time in which you can actually pose the right question. So you can go back in time to interrogate the stored picture of past events. The principle is comparable to the use researchers can make of the vast collections of past specimens held in the Natural History Museum in London. That creates a model of the natural world at the time of collection. And then you can go back and mine that model. You can mine the databases when, for example, you've had a suicide bomb attack and you want to go back and try and identify the communications that led up to the event, which of course you cannot know about till after the event has happened. The There are lots of secrets still contained in intercepted traffic. The processing complexity of a modern public key crypto system makes it, frankly, unfeasible, at least until a true quantum computer becomes available, unfeasible to access a lot of this information. My second meaning of time is as subjective experience. As Albert Einstein is said to put the point, when you sit on a park bench with a nice girl for an hour, it seems like a minute, but if you sit on a hot stove for a minute, it seems like an hour. That's relativity, he said. St. Augustine was skeptical. He famously said, "What then is time? Provided no one asks me, I know. If I want to explain it to an inquirer, I find I don't know." How could a rate of time passing be defined objectively when the measurement of a rate itself needs a measure of time? It's a circular argument. So the nature of time is, I'm sure, one of the great mysteries of physics. But the good thing for people like me is that at the blurred human scale, it's a fact that time does pass. So patience is therefore a virtue that intelligence officers must cultivate. Best current example of that is the patience that cyber attackers need to move slowly to avoid detection after penetrating a network, to consolidate your position and then allow them to pivot towards the information that they most want to steal. An enduring lesson in intelligence is that our knowledge of the world is fragmentary, incomplete, and sometimes wrong. That's an unchanging lesson. Time is needed for solving the resulting puzzles. Puzzles where the pieces of the jigsaw puzzle are mixed up, there's no lit picture on the lid, and several puzzles have their pieces mixed up along with them. And time is needed to solving those sort of puzzles. And if you're under pressure, you can't concentrate. You can't enter the productive mental state called flow that's characterized by intense absorption with an altered sense of subjective time relative to the outside world. Digital technology can help a bit to speed up the work of an analyst by making it easier to retrieve and present information, including nowadays applications of virtual reality. But the fundamental constraint on the analyst's thinking is the clock speed of the human brain. Not, I discover, an easy thing for scientists to measure, but one estimate I saw was it was around 60 bits per second. So that's a fundamental constraint on the analyst until someone has worked out how to speed up the clock speed of the human brain. Moving on to the third meaning of time as a dimension of space-time. You can associate an exact time with each physical location at, as it were, Earth-like scale. In a sense, it's the analogy of what physicists would call proper time. Henri Bergson, the philosopher, emphasized that time and space are linked, phenomenologically linked, since you can only tell the time through changes in space. The height of the burning candle, the swing of the pendulum, the emissions of the atomic clock. And it is perhaps as well that intelligence officers working at an Earth scale can ignore relativistic effects here. But the designers, of course, of the GPS navigation systems that they rely on certainly cannot. Indeed, reassembling the packets of data from bulk data intercept is going to require very exact GPS satellite timing. The study of these proper times has come to be highly significant for intelligence officers studying, for example, the timed pattern of communications between members of a terrorist or criminal group, its assumed routine significance in criminal investigations these days, particularly for the identification of suspects and elimination from further inquiries of others, which mobile phones were active at the different places associated with the movements of the criminals. 750,000 items of communication data are accessed annually by British public authorities, almost all by the police service under the law, almost all for the purpose of crime investigation and suspect elimination. We also can see that the date time stamp log of any computer operation or network operation is an essential tool of cybersecurity to detect unusual or anomalous activity. And of course, it then becomes a target for hackers to alter to conceal their activities. And finally, time as chronology. Can you infer cause and effect from the sequence of events that we observe? Time is, after all, what prevents everything happening at once. A statement which was ascribed to Einstein, but nobody's been able to track down when he ever wrote it or said it. But it's profoundly true that time is, as it were, the device for preventing everything happening at once. The standard view from David Hume in the 18th century onwards is that causation reduces essentially to the direction of time. Causes occur prior to their effects. But events can appear to follow a close temporal sequence, yet be unrelated, since they stem from a common cause. And when the analysts sit down to try and establish causes for what the intelligence reporting is telling them, in a sense, they have to deliver to their customers 4 key analytic products: situational awareness, explanation, estimation and modeling, and strategic notice. And these 4 outputs from intellectual activity I describe in my recent book, How Spies Think. Situational awareness answers the questions that start with what, when, and where, accessing data on the ground or in cyberspace. But we all know data is dumb, it needs causal explanation. Established facts may well be capable of multiple interpretation, which brings in Bayesian inference to help the analyst distinguish causes from confounding events. It's a sort of metaphorical equivalent, perhaps, of the physicist's extended present, things that don't form part of either the past or the future of some event. And a good explanation will answer the questions about how and why, and if it's a cyber attack, who. Intelligence analysts, of course, are trained to look for the explanation with the least evidence against it, not necessarily the one with most in its favor, since we all know that if you look hard enough, you can always find some evidence that appears to support an argument or even a conspiracy theory. But if you've got a good, sound, evidence-based explanation, you can move on to estimation. It's a word analysts much prefer to predict, since no one does have a crystal ball. You can estimate how events may unfold over time on different assumptions. And this answers the vital questions about what's likely to happen next if we do or do not adopt a particular policy or act in a particular way. Finally, experience teaches us that whilst we're focusing on the decision in hand, something unexpected comes and hits us on the back of the head. And strategic notice of future possible challenges that helps answer important questions of the how could we best prepare for whatever might appear next, or even how could we preempt this risk so that it never comes to test us, can be asked and answered. And if you devote effort to acquiring such strategic notice and use it sensibly, then you don't have to be so surprised by surprise itself. The remarkable fact, if you look back into the history of intelligence gathering, is the speed with which intelligence officers have taken the latest technological or scientific innovation and turned it to intelligence use. So we have Morse code, for example. We have Samuel Morse's laying of cables very quickly. Those spread around to connect the British Empire. Australia by about 1874, I think. That's the point at which the intelligence officers are already tapping the cables. Abraham Lincoln was a great fan of this approach during the American Civil War and derived quite a lot of intelligence from the tapping of cables to intercept those very early Morse code messages. By the time you've got Hart's discovering, and indeed predicted by Maxwell's equation, by the time you've got radio, then again, it's only a matter of a year or so before the intelligence officers have moved in. The world's first signals intelligence site is Scarborough, northeast coast of England, built to monitor the emissions from the German Grand Fleet, since the Germans had been the first really to take Marconi's innovation and put it on a ship. We all know the story of Bletchley Park, the pressures of the Second World War, Turing's work, the development of proto-computers, then with transistors replacing valves after the war, you get this continual development of the ability to process data. I would single out Richard Feynman's theory of quantum electrodynamics, governing the interactions of light and matter, that led to the tunable laser, and thus the ability to write, store, and read back data at scale, to transmit data in bulk over fiber optic cables, as well as to manufacture large-scale integrated circuits, all stemming from really one extraordinary intellectual breakthrough. And those technologies that stem from that give us intelligence gathering from space satellites, smartphones, mobile devices, machine learning systems, and all the rest of it. So the question sort of imposes itself, what comes next? What is the next revolution in scientific understanding that's going to act as a transforming chronophage? It may be in neuroscience. It may well be the impact of quantum computing when that becomes practicable at scale. But then history is littered with confident failures of scientific punditry, so I won't develop that further. You could say only time will tell. Let me stop there, Peter.
Thank you. Just wonderful. Thank you so much to think about now. And as I mentioned at the top of the discussion, I'm very glad to learn about the chronophage. And
it's a wonderful word.
Just wonderful, yes. So we're having a discussion on the chat, and one point that we've come to is around the question of how digitization then is affecting the intelligence investigation. So are we now in a kind of more compressed environment for the intelligence officers, for the spies themselves?
Yes, in the same way as we are as human beings. I deeply resent the expectation that I will reply to an email within hours of receipt. whereas I've had no such preconception in relation to a letter.
Yes.
Life has speeded up. The result is almost universally bad, as far as I can see, in that it drives out thought. So, you know, it's thinking fast and thinking slow. We're now compelled to think fast. British ministers, under media pressure, think faster than ever, and probably more erroneously than ever, because they haven't got the time to do the kind of thinking. I mean, I'm not talking about necessarily months of research, but you do need time to bring all the elements of a decision together. When you come to think about how do you make a decision, you're bringing two different qualities of thinking together in your mind. On the one hand, the motivations that led you to want to make a decision or to have to make a decision. So your ambitions for the decision, or your fears that you're hoping to avoid by the decision. So you've got all that emotional stuff swirling around. And then you hope that you have a rational analysis, as I've described, grounded in facts on the ground that have been properly explained, and some modeling to show you, if you decide you're going to move to the other end of the country, this is probably how it's going to pan out. And these are some of the constraints, not least the cost of housing, that might modulate that decision. But if the emotional side is too dominant, then you will not get well-grounded decisions, or if the analysis itself has been subtly distorted by the misperceptions of events on the ground, or choosing the wrong explanation because you are subconscious, you know, unconscious cognitive biases that we all know about, then you won't get good decisions either. You can see all this unfolding with COVID as we speak.
Fascinating, and I think that painting a picture of the decision maker somewhat squashed in the kind of digital decision-making machine, the cognitive process being swamped by the go back to your earlier point about crisis, by the rate of data feeding through. If I just stay with that theme for a second, I know there's more questions arriving, but Richard Berry has asked a kind of where does all this lead kind of question. As we see data speeding up through new mobile networks, 5 to 6G, etc., since where does this all lead? What will be the most important concepts of time we need to consider?
As it were, the time interval, as objectively as one can make it, technology will go on, particularly with the application of artificial intelligence, to shorten, to make greater use of the available clock time. Good example is facial recognition systems. So you can have near real time combination of a high resolution camera, lots of big computing in the cloud, some well trained AI facial recognition systems, and you just throw that up around the opening of Parliament, and you've got yourself a very good security tool. Throw it around a Chinese province, and you've got yourself a very good social repression tool. So these are the kind of issues we don't have, as far as I know. Correct me, anyone, if I'm wrong. We don't have any internationally agreed set of ethical standards for the application of artificial intelligence algorithms. I know there's work going on, but I haven't managed to find any that I would have said, that's it. We have such a set, in the same way as we have for warfare. We've got international humanitarian law based on the Geneva Conventions. I mean, it took centuries to get there, but we have actually got a pretty solid corpus. Doesn't mean to say everybody obeys it, but at least you've got international agreement on that. But we seem to be miles away from having that for what I think will be to answer your first question, what I think will be one of those deciding factors, which is the ability of the machines to compensate for the inadequacies of human cognition. We can't do that kind of visual recognition, but the machine can.
Yeah, fascinating. And just a reminder to everyone that everyone is welcome to come on the camera and ask a question on a more personal basis, if you like. But I'll just pick up this one from Alex Zafiris, which takes us in a slightly different direction, because Toralf is also making a point about acceleration is a kind of theme across all three talks today. Acceleration, and then some compression coming from that. And maybe this is a dimension of that, but Alex is making the point that some ransomware attacks paralyze large organizations, perhaps a hospital, and then ask for small ransoms of about €500. And is the small €500 really the purpose of these large attacks, or is this just, in a sense, maybe it's just the low transaction cost of being able to do a lot of damage for very little? As a motivation in itself. I don't know where we'd take that.
It's very interesting, because ransomware attacks, if you were to ask the UK National Cybersecurity Centre, they would probably say, what are you most worried about? It wouldn't be the Russian-style espionage attack, although those are very difficult to stop. It would be ransomware, because the tools to commit it are so readily available for a small price, for example, on the dark net. And there's an awful lot of it around, and it's hitting the small and medium-sized enterprise or the academic enterprise that can't afford top-of-the-range cybersecurity anyway. But I think the answer to the question is it's a combination of, you want to keep your ransom low enough so as not to trigger the big beasts of the jungle. North Koreans, for example, tried to take whatever it was, $940 billion, some extraordinarily large sum, off the central bank of Bangladesh through a rather subtle cyber attack that faked up interbank transfers. And the Bangladesh, they're in New York, where the accounts are kept, as it were. That triggered an enormous international exercise to track down who was responsible, and eventually it was pinned on North Korea. Did I say billion? I meant million, sort of 940 million. It's still a very large amount of money. They got away with about 40 million, I think, before they caught up with them. But if you're €500, no police service is going to give you the time of day. It's below the threshold that's worth investigating. And whereas in the past, you might have had a local police force if it was €500 stolen in a little from your purse, mugged in the street, the local police force would probably investigate. Now you've got, say, 5,000 victims or 50,000 victims spread around the planet, but each sum is very small. That's, so from the criminal's point of view, it's relatively safe. It wouldn't attract a big sentence if you got caught anyway. If you stole €500 by breaking into the local shop with a shotgun, you'd probably get at least 5 years. You're not going to get 5 years for a white collar crime of trying to defraud somebody. So these are all the kind of considerations, I think, in the criminal mind that lead to, let's do a lot of people with a small amount of money. And of course, you can spread your attack over 500,000 people, and it doesn't really matter if it only works in 10,000 cases. You've still made a handsome profit. You've then, of course, got to, the weak point is getting the money out of this into your bank account. So you've got to do it in Bitcoin, and Bitcoin is not infallible in security terms. So quite a few of these cyber criminals have actually got caught through the money, including human agents inside the system that are following how these things, the money trail.
I'm quite interested in the human dimension, if I can continue myself for a
Please,
second,
Peter.
which I'm not aware that I've ever met a spy. Present company may be excluded, but
the spy is the agent.
The spy is the
intelligence
agent.
officer is the manager of
Is the manager.
the agent.
Okay. Get my...
It's outside Hollywood, it's very, very rare to find that an intelligence officer can pretend to be a member of Al Qaeda and penetrate their organization. It kind of doesn't happen that way. You have to find somebody within the organization who wants to help, or is looking for a get out of jail card, or possibly doing it for money.
Yes. Okay. That's useful, and that's a few movies off my list. Don't need to watch them, but what I think I think the subjective part of the presentation that you made is really fascinating. It just made me think. And this brings us, I think you cited Bergson in there, but this brings us into this very difficult area where we're talking about clock time, or we're talking about some kind of human experience of things. And I think that that sequence of examples that you gave there is very, very fascinating. But is there a kind of resilience aspect to this as well, in the sense that trying to tie all the things together, in the sense that the officers or the spies themselves have to be prepared for incredible compression of, in the sense when they are gathering information, as the example you gave, and they're under this incredible compression of time, that in a sense, this is a kind of core skill, is just to how to cope with that momentary, just sheer momentary possibility of disaster. So is resilience I suppose, thinking aloud a little bit, but is resilience then key to the way in which we understand the work of the spy? And this is because of the temporality of it all.
Yeah, I don't know whether resilience is quite the word. You could say it's an almost psychotic lack of affect, in that here is Colonel Penkovsky, MI6 and CIA running Colonel Penkovsky back in the 1960s, with his little Minox camera that MI6
exactly.
In the few seconds that he has in front of a top secret Russian document, with somebody liable to walk through the door at any moment, yet he takes the risk and his hand does not tremble, and that's the document. And of course, that's the information that allows Kennedy to manage the Cuban Missile Crisis and identify that the Soviet launchers on Cuba are not yet operational, which gives him the breathing space to mount the blockade and actually persuade Khrushchev to back down. Yes, I think that ability to almost suspend the normal carry. Now, can you learn that? I remember talking to an Israeli military officer who said that it was explaining how they trained their analysts, indeed their soldiers, to do without sleep. Because the problem most of us have is fear of having to take life-threatening decisions without enough sleep. And that's as dangerous as the lack of sleep itself. But if you've done it many times and you've had 24 hours without sleep, and you've recognized the feelings in yourself, and you're aiming off, as it were, for the decisions you're therefore taking, you can get quite good at it. It's not necessarily something to recommend, certainly not to students about to sit their finals, but it's an interesting observation that the subjective side can be as important as the objective.
I think there'll be people in this meeting will understand it much better than me, but I am very fascinated by this relationship of what seems to be objective, although some questions there, and then the subjective side of the experience of time. Your little maybe quote from Einstein, very illustrative of that. Frank is taking us in a slightly different direction, but related to it. Rationalization and power of intelligence work is certainly diminished by digitization. This is also fueled by fake news and conspiracy agendas. So a simple question at the end of that: do we need complexity science now more than ever before in intelligence work?
That's very interesting. I don't know the answer to that. My hunch would be yes.
Yeah. I think
the question is related to a question before that might clarify the context.
Yeah.
Now you can extract lots of classified information from open sources, analysis of correlations of seemingly unrelated data in open sources.
Good point, Ariana.
Yeah. And to that extent, the boundary of what is secret intelligence has sort of narrowed. And the space has been filled with information which you don't have to steal. I mean, my definition of secret intelligence is information other people don't want you to have, and therefore you have to steal. Intelligence work is about stealing information. But there's an enormous amount you don't have to steal. You just have to understand it, understand its limitations and use it. I mean, the way that Bellingcat, for example, identified the names of those who had tried to kill Alexei Navalny is a sort of classic example of information that in a previous era you could only have got at through entirely secret means. But by teaming up with some investigative journalists, knowing the sort of sources you could go to try and pin down something like that, they've been extremely successful. So no, I mean, estimates vary. Sort of 90% of what you would need to feed a foreign secretary, to keep them up to date or help them with decision. At least 90% would be open source. But there's always a little bit that you've probably got to steal, because the only people with the information don't want you to have it, and it could be crucial.
I quite like this point, which is provocative by Alex. Maybe some of AI development is driven by the desire to offload the responsibility for difficult decisions, and not actually by consideration for efficiency or speed, etc.
I'm not sure offloading is the right word. Dispersing would perhaps be a better word, because who is going to be held accountable when the AI algorithm does something that is generally recognized to be very stupid, or possibly even illegal? It was never intended that this is what would happen, but it has happened. Is it the coder who actually made an error? Is it the project manager who decided that the training data should be of a particular kind and that wasn't representative of the actual population the AI was being used on? Was it the politician who agreed to the system being brought into operation? Who is in the end to be held accountable? And I don't think we've got a satisfactory answer to that. In the case of a weapons system, we kind of do, which is why you can't introduce a new weapons system under international law until you have actually gone through, satisfied yourself about the risks of collateral damage, known who takes that decision to allow it onto the battlefield. But AI probably not yet at that point. But yes, of course, there will be mistakes. It was Alan Turing, wasn't it, who said that you can't have a machine that's intelligent and that doesn't make mistakes. I paraphrase slightly, but it's a profoundly true statement from Turing.
But there's so the point of regulation is one that I can maybe just come to quickly, because you raised that point around AI, that we are going into an area where regulation is in a sense impossible because we don't know what we have yet. And Richard was also adding that we don't actually have international agreement on the, Richard Berry, on the standards of data as evidence as well. You know, we don't actually understand what can be considered as evidence, certainly in criminal trials, for example.
Yeah, and you can, without too much difficulty, model a situation where the evidence, I put that in inverted commas, the identification of the suspect, let's say, by AI is considerably more accurate than the identification by human witnesses, who are notoriously bad at remembering.
True.
Yet a court will not accept
yes.
The evidence from the AI, and will insist on there being something that, if you like, old-fashioned thinking can connect back to the suspect. Otherwise, it's just circumstantial. But we're moving into a world where the just circumstantial is likely to be more accurate. But it offends against our human sense of justice.
Yes.
Why should this individual be convicted when there's the only evidence is the combination of 100 different factoids, all of which tend to point to this individual, but none of which is definitive. But the probability of that individual being guilty is much greater than the probability of somebody who will be found guilty by the jury on the basis of some pretty iffy visual observation in bad weather by
somebody who was thinking about something else.
Yeah.
Yes. No, absolutely. I do know that there, and again, I think Richard Berry could confirm, but there are, there is case evidence whereby trial evidence, case history, whereby people have been convicted on probability now, rather than of electronic traces and so on and so forth. Great. Any more questions from the floor, please?
Bellingcat, by the way, is not funded by the intelligence services and can sometimes be a bit of a thorn in the side, because they're revealing things which the intelligence services probably know, but probably had some reason for not revealing. So they are definitely an independent organization.
Oh, that's good to know. And I think there's also a debate about the Stratfor, whether they are current or ex-CIA officers. Wonderful. If no more questions, then I think we are about to say thank you so much and goodbye, I think. Marcia?
Thanks. Yeah. I've been genuinely fascinated by this and reading all the details in the chat as well. I have to say this has probably generated the most lively chat I have seen in ages. It's been absolutely fantastic. I'm going to try to make sure we capture it before it goes away. But I wanted to thank everybody. I wanted to thank all three speakers, and also Ksenia, who has acted as interlocutor, and
wonderful, yes.
Peter, who kind of really managed to chair this really beautifully and manage that with Ariana and all monitoring the chat. So I think there was a real team effort, and I think each of the presentations was completely fascinating, but also I thought they had a wonderful way of speaking across and starting to raise some much bigger issues around time for us and really giving us some insights. So again, this has been a fabulous event. Thank you to everyone who's taken the time out to come to it as well and to get involved in discussing it. We are recording, so we will ultimately have the record of this too, so that if people want to hear some of the detail of the conversations or the papers again, they're very welcome. But thank you to each of our fellows and speakers, and the conversation from earlier when we were welcomed by the Vice Chancellor and Pro Vice Chancellor. is accurate. So those who are joining us, Jason and David, particularly from away from Loughborough, you are very welcome once we are open, and we do hope that you will at some point perhaps come and visit us at International House and meet with us live, and let us offer you some hospitality as well as being on screen, because we'd love to do that and catch up. So thank you very, very much. Goodbye, everyone. Good evening.
Thank you so much.
Appreciated. Take care.
Thank you.
Bye-bye.
Bye-bye. Thank you.